Acids, bases and salts. Exercises. Q1. Identify the odd one out and justify. A chloride, nitrate, hydride, ammonium B hydrogen chloride, sodium hydroxide, calcium oxide, ammonia C acetic acid, carbonic acid, hydrochloric acid, nitric acid D ammonium chloride, sodium chloride, potassium nitrate, sodium sulfate E sodium nitrate, sodium carbonate, sodium sulfate, sodium chloride F calcium oxide, magnesium oxide, zinc oxide, sodium oxide. G crystalline blue vitriol, crystalline common salt, crystalline ferrous sulfate, crystalline sodium carbonate. H sodium chloride, potassium hydroxide, acetic acid, sodium acetate. Answer. The odd one's ammonium. Explanation. Ammonium NH4+ is the odd one out because it is the only positively charged ion cation. While chloride Cl, nitrate NO, and hydride H are the negatively charged ion anion. B. The odd one's hydrogen chloride. Explanation. Hydrogen chloride is odd one out because it is the only acid among the given compounds. While sodium hydroxide NaOH, calcium oxide SaO, and ammonia NH3 are the bases. C. The odd one's acetic acid. Explanation. Acetic acid is odd one out because it is the only organic acid. While carbonic acid, hydrochloric acid and nitric acid are inorganic acids. D. The odd one's ammonium chloride. Explanation. Ammonium chloride is the odd one out among the given compounds because it is an acidic salt. While sodium chloride, potassium nitrate, sodium sulfate are the neutral salts. Note: acidic salts are formed by the neutralization reaction between a strong acid and a weak base. Neutral salts are formed by the neutralization of a strong acid and a strong base. Salts are formed by the combination of acid and base. The reaction takes place is called neutralization reaction. E. The odd one's sodium chloride. Explanation. Sodium chloride is the odd one out because it is the only neutral salt present. F. The odd one's ZNO. Explanation. ZNO is odd one out because it is the only amphoteric oxides among the given oxides. While SaO, MgO and Na2O are basic oxides. G. The odd one's crystalline common salt. Explanation. Crystalline common salt is the odd one out because it does not lose its crystallization on heating. H. The odd one's potassium hydroxide. Explanation. Potassium hydroxide is odd one out because it is not salt, while all others are salts. Q2. Write down the changes that will be seen in each instance and explain the reason behind it. 50 ml water is added to 50 ml solution of copper sulfate. Answer. The changes observed when 50 ml water is added to 50 ml solution of copper sulfate are: I. A reversible reaction takes place. E. Color of copper sulfate changes. E. Anhydrous copper sulfate changes to hydrated copper sulfate. Explanation. The changes occurred due to the following reaction. The water of crystallization is taking place in the above reaction. Thus, the color changes from white to blue. Q2. B. Write down the changes that will be seen in each instance and explain the reason behind it. 2 drops of the indicator phenolphthalein were added to 10 ml solution of sodium hydroxide. Answer. The change observed when 2 drops of the indicator phenolphthalein was added to 10 ml solution of sodium hydroxide is: the solution changes from colorless to dark pink in color. Explanation. Phenolphthalein is a basic indicator. I. When it is mixed with any acid, it remains colorless. E. When mixed with any base, its color changes to pink. NaOH is a base. Thus, the solution becomes dark pink in color. Q2C. Write down the changes that will be seen in each instance and explain the reason behind it. 2 or 3 filings of copper were added to 10 ml dilute nitric acid and stirred. Answer. The changes observed when 2 or 3 filings of copper were added to 10 ml dilute nitric acid and stirred are: I. The solution changes to bluish red. E. A red toxic gas is evolved. E. Copper is completely consumed. Explanation. The changes occurred due to the following reaction. Cu plus 4HNO3 right pointing arrow Cu, number 3, 2 plus 2 number 2 plus 2H2O. In the above reaction, the copper metal is oxidized by nitric acid. The nitrogen dioxide, number 2, formed in the reaction is so dangerous and toxic. Q2. D. Write down the changes that will be seen in each instance and explain the reason behind it. A litmus paper was dropped into 2 ml dilute HCl. Then 2 ml concentrated NaOH was added to it and stirred. Answer. The changes observed when a litmus paper was dropped into 2 ml dilute HCl. Then 2 ml concentrated NaOH was added to it and stirred are: I. With HCl, the litmus paper turns red. E. With NaOH, the litmus paper turns blue. Explanation. HCl is an acid and has pH lesser than 7, thus its color changes to red. NaOH is a base and has pH greater than 7, thus its color changes to blue. Q2. E. Write down the changes that will be seen in each instance and explain the reason behind it. Magnesium oxide was added to dilute HCl and magnesium oxide was added to dilute NaOH. Answer. The changes observed when magnesium oxide was added to dilute HCl and magnesium oxide was added to dilute NaOH are: I. With HCl, magnesium oxide forms salt and water. E. With NaOH, no reaction takes place. Explanation. When magnesium oxide being a basic oxide reacts with HCl, an acid, it forms a salt. MgO plus HCl right pointing arrow MgCl2 plus H2O. The above reaction is an example of neutralization reaction. On the other hand, when magnesium oxide being a basic oxide reacts with NaOH, a base, no reaction takes place. Because to carry out a neutralization reaction, there must be a combination of acid and base. But here both are bases, that's why no reaction takes place. Q2F. Write down the changes that will be seen in each instance and explain the reason behind it. Zinc oxide was added to dilute HCl and zinc oxide was added to dilute NaOH. Answer. The changes observed when zinc oxide was added to dilute HCl and zinc oxide was added to dilute NaOH are: I. With HCl, zinc oxide forms salt and water which shows basic properties. E. With NaOH, zinc oxide forms salt and water which shows acidic properties. Explanation. Zinc oxide is an amphoteric oxide which shows both the properties of an acid as well as a base. When zinc oxide reacts with HCl, acid, shows basic properties. ZNO plus HCl right pointing arrow ZnCl2 plus H2O basic nature. When zinc oxide reacts with NaOH, base, shows basic properties. ZNO plus NaOH right pointing arrow Na2 ZNO2 plus H2O acidic nature. Q2. G. Write down the changes that will be seen in each instance and explain the reason behind it. Dilute HCl was added to limestone. Answer. The changes observed when dilute HCl was added to limestone are: I. Effervescence of carbon dioxide gas is formed. E. Bubbles are also produced. Explanation. When dilute HCl was added to limestone, CaCO3 effervescence of carbon dioxide is formed due to the following reaction. CaCO3 plus 2HCl right pointing arrow CaCl2 plus H2O plus CO2. Q2. H. Write down the changes that will be seen in each instance and explain the reason behind it. Pieces of blue vitriol were heated in a test tube. On cooling, water was added to it. Answer. The changes observed when pieces of blue vitriol were heated in a test tube and on cooling, water was added to it are: I. On heating, the crystalline structure of blue vitriol broke down to form a colorless powder. E. On adding water, the color changes back to blue color. Explanation. When blue vitriol, hydrated CuSO4, is heated, it becomes anhydrous and colorless white. CuSO 4.5 H2O right pointing arrow CuSO 4 plus 5 H2O blue, white. Now, when water was added, it regained its blue color and becomes hydrated again. CuSO 4 plus H2O right pointing arrow CuSO 4.5 H2O white hydrated. Q2. I write down the changes that will be seen in each instance and explain the reason behind it. Dilute H2SO4 was taken in an electrolytic cell and electric current was passed through it. Answer. The changes observed when dilute H2SO4 was taken in an electrolytic cell and electric current was passed through it are: I. Conduction of electricity becomes better. E. So 42 remains in the solution. The acid makes the electrolytic cell a better conductor. The reaction takes place is H2SO4 right pointing arrow 2H plus SO42. Q3. Classify the following oxides into 3 types and name the types: SO, MgO, CO2, SO3, Na2O, ZNO, Ai2O3, Fe2O3. Answer. There are 3 types of oxides. I. Acidic oxides. Acidic oxides are the oxides of nonmetals. When these oxides are combined with water, they form acid, and when combined with base, form salts. CO2 and SO3 are the acidic oxides. E. Basic oxides. Basic oxides are the oxides of metals. They combined with water to form hydroxides, and when combined with acid, they form salts. SO, MgO and Na2O are the basic oxides. Q3. Classify the following oxides into 3 types and name the types: SO, MgO, CO2, SO3, Na2O, ZNO, Ai2O3, Fe2O3. Answer. There are 3 types of oxides. I. Acidic oxides. Acidic oxides are the oxides of nonmetals. When these oxides are combined with water, they form acid, and when combined with base, form salts. CO2 and SO3 are the acidic oxides. E. Basic oxides. Basic oxides are the oxides of metals. They combined with water to form hydroxides, and when combined with acid, they form salts. SO, MgO and Na2O are the basic oxides. E. Amphoteric oxides. These are metallic oxides and exhibit the property of both acid and base. When react with an acid, they form salt and water. This shows the basic properties. When react with a base, they form salt and water. This shows the acidic properties. ZNO, Al2O3 and Fe2O3 are the amphoteric oxides. Amphoteric oxides. These are metallic oxides and exhibit the property of both acid and base. When react with an acid, they form salt and water. This shows the basic properties. When react with a base, they form salt and water. This shows the acidic properties. ZNO, Al2O3 and Fe2O3 are the amphoteric oxides. Q4. Explain by drawing a figure of the electronic configuration. Formation of sodium chloride from sodium and chlorine. Answer. The atomic number of sodium, Na, equals 11. The electronic configuration of 11 Na equals 2, 8, 1. The atomic number of chlorine, Cl, equals 17. The electronic configuration of 17 Cl equals 2, 8, 7. Na transfer its 1 electron to Cl, so that it can achieve noble gas configuration 2, 8, whereas Cl accepts 1 electron from Na so that it can achieve noble gas configuration 2, 8, 8, as shown below. Q4. B. Explained by drawing a figure of the electronic configuration. Formation of a magnesium chloride from magnesium and chlorine. Answer. The atomic number of magnesium, Mg, equals 12. The electronic configuration of 12 megagrams equals 2, 8, 2. The atomic number of chlorine, Cl, equals 17. The electronic configuration of 17Cl equals 2, 8, 7. Mg transfer its 2 electrons to each Cl, so that it can achieve noble gas configuration 2, 8, whereas each Cl accepts 1 electron from Mg so that both can achieve noble gas configuration as shown below. Q5. Show the dissociation of the following compounds on dissolving in water, with the help of chemical equation, and write whether the proportion of dissociation is small or large. Hydrochloric acid, sodium chloride, potassium hydroxide, ammonia, acetic acid, magnesium chloride, copper sulfate. Answer. 1. Dissociation of hydrochloric acid in water. HCl, right pointing arrow H++ Cl. The proportion of dissociation as large as 100% of the HCl dissociates into ions. 2. Dissociation of sodium chloride in water. NaCl, right pointing arrow Na++ Cl. The proportion of dissociation is large as it completely dissolves in water. 3. Dissociation of potassium hydroxide in water. O, right pointing arrow K++ OH. The proportion of dissociation is large as it completely dissolves in water. 4. Dissociation of ammonia in water. NH3 plus H2O, right pointing arrow NH4 OH. The proportion of dissociation is large as it completely dissolves in water due to formation of hydrogen bonding. 5. Dissociation of acetic acid in water. CH3COOH, right pointing arrow CH3COO plus H+. The proportion of dissociation is small. 6. Dissociation of magnesium chloride in water. MgCl2, right pointing arrow Mg2 Cl. The proportion of dissociation is large as magnesium chloride is highly soluble in water. 7. Dissociation of copper sulfate in water. CuSO4, right pointing arrow Cu2 SO42. The proportion of dissociation is medium. Q6A, write down the concentration of each of the following solutions in gram per liter and mole per liter. 7.3 grams HCl in 100 milliliters solution. Answer. Given. Weight in grams equals 7.3 grams. Volume in liters equals 100 milliliters equals 0.1 L, 1 ml equals 1/1000th L. Molecular mass of HCl equals 1 plus 35.4 equals 36.4 grams per mole. Concentration in gram per liter equals 73 grams per liter. Concentration in mole per liter equals 2 moles per liter. Thus, concentration in gram per liter is 73 grams per liter and concentration in mole per liter is 2 moles per liter. Q6B, write down the concentration of each of the following solutions in gram per liter and mole per liter. 2 grams NaOH in 50 milliliters solution. Answer. Given. Weight in grams equals 2 grams. Volume in liters equals 50 milliliters equals 0.05 L, 1 ml equals 1/1000th L. Molecular mass of NaOH equals 23 plus 16 plus 1 equals 40 grams per mole. Concentration in gram per liter equals 40 grams per liter. Concentration in mole per liter equals 1 mole per liter. Thus, concentration in gram per liter is 40 grams per liter and concentration in mole per liter is 1 mole per liter. Q6C, write down the concentration of each of the following solutions in gram per liter and mole per liter. 3 grams CH3COOH in 100 milliliters solution. Answer. Given. Weight in G equals 3 grams. Volume in L equals 100 milliliters equals 0.1 L, 1 ml equals 1/1000th L. Molecular mass of CH3COOH equals 12 plus 3 times 1 plus 12 plus 16 plus 16 plus 1 equals 60 grams per mole. Concentration in gram per liter equals 30 grams per liter. Concentration in mole per liter equals 0.5 mole per liter. Thus, Concentration in gram per liter is 30 grams per liter and concentration in mole per liter is 0.5 moles per liter. Q60. Write down the concentration of each of the following solutions in gram per liter and mole per liter. 4.9 grams H2SO4 in 200 milliliter solution. Answer. Given. Weight in grams equals 4.9 grams. Volume in liters equals 200 milliliters equals 0.2 L, 1 ml equals 1/1000th L. Molecular mass of H2SO4 equals 2 times 1 plus 32 plus 4 times 16 equals 98 grams per mole. Concentration in gram per liter equals 24.5 grams per liter. Concentration in mole per liter equals 0.25 moles per liter. Thus, concentration in gram per liter is 24.5 grams per liter and concentration in mole per liter is 0.25 moles per liter. Q7. Obtain a sample of rainwater. Add to it a few drops of universal indicator. Measure its pH. Describe the nature of the sample of rainwater and explain the effect if it has on the living world. Answer. If the pH of rainwater is less than 7, it means its nature is acidic. If the pH of rainwater is above 7, it means its nature is basic. If the pH of rainwater is 7, it means its nature is neutral. Natural rainwater has a pH around 5.6 and is slightly acidic. If value of pH is below pH, then it is considered as acid rain. Acid rain particularly damages I. Lakes, rivers, streams. E. Forests. E. Plants and animals. IV. Human beings, especially damages the skin. Q8. ANSWER the following questions. Classify the acids according to their basicity and give one example of each type. Answer. Basicity of acids. The number of H+ ions obtainable by the dissociation of one molecule of an acid is called its basicity. Q8. B. Answer the following questions. What is meant by neutralization? Give 2 examples from everyday life of the neutralization reaction. Answer. In the neutralization reaction, an acid reacts with a base to form a salt and water. Everyday examples. I. Toothpastes help in neutralizing the effect of acid because they are alkaline in nature and neutralize the effect of acid present in our mouth. E. Use of baking soda in cooking. E. To reduce acidity in the stomach, we take milk of magnesia MgO2. Q8C. Answer the following questions. Explain what is meant by electrolysis of water. Write the electrode reactions and explain them. Answer. Electrolysis of water. It is defined as the process of decomposition of water into hydrogen and oxygen gas by the passage of electricity through its aqueous solution water. I. At the cathode negative electrode, reduction takes place and evolves hydrogen gas. Reduction reaction. 2H++ 2E. Right pointing arrow H2. E. At the anode positive electrode, oxidation takes place and evolves oxygen gas. Oxidation reaction. 2H2O. Right pointing arrow O2 plus 4H++ 4E. E. Overall cell reaction. 2H2O. Right pointing arrow 2H2 plus O2. Q9. Give reason for the following. A hydronium ions are always in the form H3O+. B. Buttermilk spoils if kept in a copper or brass container. Answer. A dissociation of water molecule. H2O left right arrow H++ OH. As soon as the H+ ions are formed, they make bond with water molecules in the solution to form hydronium ion H3O+. This is because hydrogen cannot exist independently, alone, in the aqueous solutions, and hence take the form of the hydronium ion. H2O plus H plus left right arrow H3O+. Water has ability to attract H+ because it is a polar molecule. B. Buttermilk spoils if kept in a copper or brass container because I. Buttermilk contains lactic acid. E. The lactic acid present in the buttermilk reacts completely with copper or brass container. E. Due to the chemical reaction taking place, The buttermilk becomes unfit for consumption and spoils the buttermilk. Q10. Write the chemical equations for the following activities. A NaOH solution was added to HCl solution. B. Zinc dust was added to dilute. C. Dilute nitric acid was added to calcium oxide. D. Carbon dioxide gas was passed through co-solution. E. Dilute HCl was poured on baking soda. Answer. When NaOH solution was added to HCl solution, it formed sodium chloride and liberated hydrogen gas. HCl plus NaOH, right pointing arrow, NaCl plus H2. B. When zinc dust was added to dilute H2SO4, it formed zinc sulfate and liberated hydrogen gas. H2SO4 plus Zn, right pointing arrow, ZnSO4 plus H2. C. When dilute nitric acid was added to calcium oxide, it forms calcium nitrate and water. 2HNO3 plus SO, right pointing arrow, Ca, number 3, 2 plus H2O. D. When carbon dioxide gas was passed through co-solution, it was completely absorbed by CO. CO2 plus CO, right pointing arrow, KHCO3. E. When dilute HCl was poured on baking soda, NaHCO3, it forms a salt NaCl, water, and releases bubbles of carbon dioxide. NaHCO3 plus HCl, right pointing arrow, NaCl plus H2O plus CO2. The above reaction is an example of neutralization reaction. Q11A. State the differences. Acids and bases. Answer. Difference between acids and bases. Q11B. State the differences. Cation and anion. Answer. Difference between cation and anion. Representation of cation and anions. Q11C. State the differences. Negative electrode and positive electrode. Answer. Difference between negative electrode and positive electrode. Representation of anode and cathode. Q12. Classify aqueous solutions of the following substances according to their pH into 3 groups. 7, more than 7, less than 7. Common salt, sodium acetate, hydrochloric acid, carbon dioxide, potassium bromide, calcium hydroxide, ammonium chloride, vinegar, sodium carbonate, ammonia, sulfur dioxide. Answer. Q13. Collect information about electroplating. Make a list of articles in day-to-day life where this technique is used. Answer. Electroplating. In this process, electric current is passed through electrolyte. I. 2 electrodes are dipped in the solution. E. Connecting with a circuit and a battery. E. The electrodes and electrolyte are made from chosen elements. IV. On passing electric current, splitting of electrolyte takes place and some of its parts deposits to one of the electrode at the top B. As a result, one of the electrode becomes electroplated. Basically, the electroplating is the coating one metals with another metal. Electroplating of silver onto spoon. List of articles in day-to-day life where electroplating is used. I. Gold and silver coating is done in ornaments. E. Iron is coated with tin to make fresh containers. E. In machine parts, zinc coating is done. IV. In cars, nickel coating is done. B. In handle of cycles and wheels, chromium coating is done to give an extra shine.
Let's get higher.